of x equals -1. So to undo log base 3, use this 3. The reason it's 3 is it's got to match the thing you're taking the log of. All right, so what that means is this undoes it over here. So 3 to the log base 3 of x, that undoes it. X equals, and then you get 1/3 on the right. Does that make sense?
Yep.
3 to the -1s. Okay. So the idea is like you undo the log with the, so part B, you undo log base 2 with the 2. So you can say 2 to the log base 2 of x equals 2 to the -4. These undo each other, so you just get x equals 1/2 to the 4th, like that. Is that okay? Clear?
Yep.
All right. All right. What next? Where should we go from here? To the next derivative stuff, derivative grouping.
Yeah, like the 39 through 45.
So yeah, let's do 39. We'll do a bunch of these. This is really what you need to practice. This is what this is what's going to help you for the test. So the rule is d u of a to the u. So it's a number to a variable. So that number to the variable a to the 4, I guess they don't look right. It's itself times the natural log of the base, but then there's this chain rule u prime. So we'll see that in the next primary, but for the derivative of this one is itself times the natural log of the base. That make sense?
Yep.
All right, so for the next one here, this will make more sense for the next one. Number 40. So this time the u is 4 to the x, or I'm sorry, it's 4x. So f of x is equal to 3 to the u. So the derivative here is itself times the natural log of the base, which is 3. The base is the number below the exponent, times u prime. And that's where you got to have this u prime thing figured out. You got to be like, okay, I got to be comfortable taking the derivative. So what is the derivative of 4x?
4.
4. So u prime is 4. So you just start plugging that stuff back in. 3 to the 4x times the natural log of the base times 4. Now, I think it's a little uncomfortable is there's actually nothing you can multiply together. So the way this is maybe written on your multiple choice is 4 natural log of 3 times 3 to the 4x, but you can't combine anything.
Okay.
Any questions that for me, just more difficult ones?
Nope.
Okay. All right, so the next one we probably look at is like 41. Actually, we'll do 42 next. I'll have you do 41. So 42 here, your u is the exponent. So u is equal to 3x minus 4. So it's y equals 6 to the u. And so your derivative is itself times the natural log of the base times u prime. And u prime here is just 3. So you know, you can choose to decide if you want to actually like do it all at once or just put those back in when you're done. So it's 6 to the 3x minus 4, natural log of 6 times 3, like that.
Okay.
Any questions on that?
No.
Okay. Why don't you try 41? Do you want me to snip that in, or yeah, actually let me snip that in.
Yes, please.
Snip that here. And we'll move on to some more difficult questions involving product rule, power rule, stuff like that.
-4 times 5 to the -4x, natural log of 5.
Good. Yeah, that is correct. That's the full derivative there. So that's good. It's good that you can do that and you know, kind of have a good idea of how to work that out there. All right. Wow. Okay. So all right, so the next grouping of problems is, you know, like power rule, product rule stuff. So let me do 44 and then I'll maybe try 43 because it's a little bit. All right, so the when you're doing product rule here, product rule here, you want to make sure you know the two things. So F and G, F is minus 7x, G is 8 to the minus 2x, like that.
So you want me to,
No, yeah, I'm just sort of throwing that out there. Sorry,
okay,
I'm just trying to slow down here. So
well, that's okay.
derivative of the first one is -7. Why don't you give me the derivative of the second one? It's kind of like the ones you've been doing.
Okay. -2 to the power of 1 minus 6x natural log of 8. Did I?
You could minus, sorry, this is the correct answer. I thought I heard a 6 somewhere in there, but
Oh, no, no.
okay. All right, so that's good. So now the derivative, product rule is the derivative here. You got to pair them up. So it's minus 7x times -2 times 8 to the minus 2x natural log of 8 plus -7 times 8 to the minus 2x. Now, you can combine some stuff here. So like the minus 7x to the minus 2 is 14x. You could bring the natural log of 8 to the minus 2x. -7 times 8 to the minus 2x, but you can never combine like the two bottom numbers there. So just keep that in mind. Any questions on that?
Nope.
Okay. All right. Where do we go from here? Okay, why don't I have you try number, yeah, so why don't you try number 43? It's a little bit easier, but it's kind of the same approach here. You're welcome to use that F and G if you want.
Okay. X times 9 to the power of x natural log 9 plus 9x.
Sorry, you said natural log of 9 here.
Yeah,
Plus
natural log 9
plus
plus
9 to the x.
yeah.
Good. And then, again, you can always factor stuff out here. So like you could factor out a 9 to the x from both. X natural log of 9 plus 1 would be a possibility here. So all right. Any questions on that?
Nope.
Okay. Okay, so let's I mean, is there any other ones on the derivative front there that you want us to do before we move to like the tangent line and the logarithmic differentiation?
Which number set are you looking at? Sorry.
61 through 64 would be kind of the next grouping to look at.
Can we do 61?
All right, so the tangent line, we've talked at length, you need a point and a slope. So you have a point, you need a point. So I want you to calculate the derivative for us, please.
-2 to the power of -x natural log of 2.
It's -2 to the power of negative, yeah, times the natural log of 2, good. Okay, and then we've got to put in the value of -1 in for x. So it's -2 to the negative of -1 natural log of 2. So these two negatives cancel and you get 1. 2 to the 1 is 2. So the answer is -2 natural log of 2. That is your slope, even though you may not like it. That is absolutely the slope there. And keep that in mind. So all right. So the tangent line, you're right, you go with point slope for y minus y1 equals slope x minus x1. And we already have our x1 and our y1. So it's y minus 2 equals -2 natural log of 2 x plus 1, because the negative results like that. They might move the 2 over, they might not, couldn't tell you. All right. So we should probably not do another tangent line. I mean, those are all the same. Let's go to logarithmic difference. Do you have to do any from 65 through 66?
65, I think.
Yeah, we should do 65. Okay. This is a classic kind of test question, which we've done a few times here. So the first thing is you take the natural log of both sides of the equation. And you can bring the exponent out in front. So like the 2 to the x is normally up here, but you can bring it out in front. And then on the right, this becomes a product rule problem for derivative. So your f is 2 over x, your g is natural log of x. So would you calculate f prime and g prime for us, please?
Yeah. F prime is -2x squared, -2 over x squared.
Good.
And G prime. G prime is 1 over x.
Okay. So the derivative on the left is 1 over y prime. I remember when you take a derivative with respect to y, it's always implicit. Yeah, especially in this case. And that will help here. So then it's product, right? It's the just multiplying like the ones diagonally. So like 2 over x times 1 over x, f g prime. plus, but it's really a minus because of that there. So minus 2 over x squared, natural log of x. And then the last thing you do here, so I thought we did this in a previous lesson, is you multiply both sides by y. So your y prime is everything we just wrote. And you can simplify if you want here. Times y, and remember y is the original function. So your derivative always has that original function in it. Like that.
Okay. Oh, excuse me, there's someone at my door.
Sure.
Sorry about that.
All right, everything's okay.
Yep.
All right, so that is the derivative. You're always going to have the original function in there when you do implicit derivative like that. So, okay. Can we go to 69 or, kind of that next grouping of finding indefinite integral, or do you have more questions, or do you want us to do another logarithmic?
No, we could go to
Derivative.
69. That was the next one I was gonna say.
Okay. Yeah, there's a bunch here to do for the rest of the lesson. So, this one, the integral of 3 to the x, you have to have a rule here. So the integral of 3 to the u, or I'm sorry, it's a to the u. I guess maybe they use b. They probably use b in both. B to the u du is itself, but you actually divide by the natural log of b plus c. Okay, and the reason you divide by it is that when you take the derivative of the original function, you multiply by the natural log of the base. And when you multiply by it, and divide by it, it ends up canceling out. So this is the answer here is that it becomes 3 to the x over the natural log of 3 plus c, like that.
Okay.
You might think, oh, I got it, no big deal. And then 70's actually got a little bit more to it. So 70 moves again into that u substitution stuff. Your u is the exponent, so it's really the integral of 2 to the u. Your du is minus 1 dx. So your dx, solve for dx, it's du over -1 or minus du, depending on how you want to do it. So your dx is du over -1. This minus does not go with this. Like, it just kind of hangs out in front. Like, you can't apply it to this. Like, there's really parentheses here. And so just don't make that mistake of thinking you can just immediately assign it to that value. It's really negative the integral 2 to the u du. And from the previous problem, we know that the antiderivative of this is negative 2 to the u over the natural log of 2 plus c. And then u is minus x. So we have to back substitute that into the equation. So we have minus 2 to the minus x over the natural log of 2 plus c. Right, so where this gets challenging is remembering this rule with all the other rules that we have. There's so many that you have here. It's difficult. That's why having that reference sheet handy is always a good idea. This is really the integral of x squared dx plus the integral of 2 to the minus x dx. So I just did one exactly like this one on the right. So why don't you try, well, or you just read me the answer from the, actually, I guess it's exactly the same. So we're not gonna do that. It's the exact same one. It's 2 to the minus x negative over the natural log of 2 plus c. What do you remember the derivative of this x squared, not derivative, integral, antiderivative, this power rule?
X to the third over 3.
X to the third over 3, like that. Okay. And then that's your answer. So what I was trying to get at is like sometimes it's hard, like you gotta see the difference. Like this is x to a number, this is a number to x to a number to x. And they're different. They're different ways. And you solve them differently. So just keep that in mind. All right. Let's look at 73 next. 72, sorry, we'll do 72. Actually, why don't you try 72? It's very similar to the ones we've just done, so. Um,
One-fifth x to the fifth plus 1 over the natural log of 5 times 5x, or 5 to the x plus b.
Yeah. Let's see, yeah. Yeah, and just be really careful when you look at the answers, like this and 5 to the x are not the same. I don't know how they're going to format it, but you just gotta be real careful there. All right, good. So the next couple of problems here move into like the substitution problems we've been doing, the more complicated integration. But let's take a look here. I'm going to do 74 first. Typically your u is the exponent, the full 4 minus x squared. So will you take a derivative of that for us, please?
Yeah. Uh, 2x minus 8.
So it's powerful. So it's then being 2
Oh.
times 4 minus x, and then you have to take the derivative of the inside function. The inside function being 4 minus x. So derivative of 4 is 0. Derivative of minus x is minus 1. So u prime here is -2 times 4 minus x. And if you simplify, which you don't want to do here, but you could, and then there's a dx here, but you don't want to simplify. You typically want to leave it in factored form, typically,
Oh.
and you'll see why here in a moment. It's because you're going to cancel it out with something in here. So remember, you always solve for, and I did this wrong. It's du. So dx is du over -2 times 4 minus x. So that becomes the integral 4 minus x, 6 to the u. Instead of dx, it's du over -2 times 4 minus x. And you can see that the 4 minus x's cancel. Don't know why I did that, but the 4 minus x's cancel. That's another way to kind of decide if your u is right, is the derivative end up appearing back in the original, and it does. So this -2 on the bottom is really -1/2 integral 6 to the u du, like that. And so you can see now, like this is one we can do. It becomes 6 to the u over natural log of 6, and then you bring the -1/2 down plus c. Questions on that?
Nope.
Okay. Let's look at 73 now. All right, so the u in this case is minus x squared. Can you give me the derivative of it, please?
-2x.
-2x dx. All right. So why don't you take over from here? You're gonna put your u back in. You're gonna solve for dx, replace that. You're gonna see that the x's cancel. You'll have a fraction, and then you'll integrate like we've been doing.
-1/2 natural log of 5 times 5 to the -x squared plus c.
Okay, do I have it written down close to the what you meant?
Yeah.
Good. Yep, this is correct. Really good. All right. Let's go to the next page. Start with 78. Yeah. All right, so like ignore the bounds for a moment. It's from -4 to 4, but when you look at this right in here, you gotta again go to this u substitution stuff. You gotta say, okay, it's 1/4 times x. Du is 1/4 dx, like that. And so dx is for du. So you substitute in 3 to the u, instead of x over 4, that's u. Instead of dx, it's 4 times du. So that 4 can come out. That's typically where most students like to bring the constant. I think it's a good idea. Now the question is are you going to integrate with respect to u and evaluate with respect to u like we did yesterday? I think you put the bounds in. Are you going to put the bounds into this right here? And that's your choice, because if you do, then you can just integrate with respect to u and you're done. If you don't, you have to then you have to go back to x and and evaluate that way. Is that okay?
Yep.
All right. So I suggest like doing the u of -4, which is 1/4 times -4, which is -1. U of 4, which is 1/4 times 4, which is 1. -1 to 1 like that. I would do it that way. So the antiderivative of 3 to the u, like that's the same whether there's bounds or not, whether it's a definite or indefinite integral. It's still 3 to the u over natural log of 3. This 4 comes out in front, but then you're evaluating from -1 to 1. So that means you're putting it, and it's always top minus bottom. Okay, so it's 4 over natural log of 3, 3 to the 1, minus 4 over natural log of 3, times 3 to the -1. All right, so 4 times the 3, that's 12. 12 over natural log of 3. And then 3 to the -1 is 1/3. So I guess we can go -4 over 3 natural log of 3. You could factor stuff out here. I don't know that they would do all that, but that is something to consider when you're working through this. So why don't you try number 77? You don't have to make any u substitutions. You just gotta find the antiderivative. You've got to evaluate the endpoints. It's actually much easier than what I just did. But give that a try. You do get a numerical answer. It's not too bad. I mean, it's got a natural log of 2 in there, but
Okay, 4 over natural log of 2 minus 1 over 2 times the natural log of 2.
so good news on that front is, like sometimes it's okay. Get a nice answer, and that's what you got. All right. Okay. Let's see, next one here. Okay. Okay. This is really similar to the last one. You might as well try this one on your own. It's just two separate integrals. One for 5 to the x, one for 3 to the x.
Okay, 4 over the natural log of 5 minus 2 over the natural log of 3.
Okay, oh, I see. Did okay. I just, so the first one here, let me write it out here because I'm struggling to see where that came from. So the first one is 5 minus 1, and that's where you got the 4, is that right?
Yeah,
Okay. So this could appear in a variety of ways. Minus 3 to the x over natural log of 3, also valued from 0 to 1. So that's the 2. Okay. All right, very good. All right, any other questions you want us to look at
nope,
today? Okay. All right, let's it's okay if we close out here.
yep, that's fine.
All right.